and gentlemen, so today we're going to look at natural logs. So you're going to want to have your notes, a pen or a pencil, and a calculator. So, special types of logs. So you've been looking at common logs, base 10, that's the log button on your calculator basically. Now, there is such a thing called a natural log. Now, a natural log is not a log that's grown in a forest. It is a log with a base of E. So what you're going to want to start associating with is that log base E is equal to ln. ln. So natural log is log base E. Someone long time ago realized, let's make log base E, let's make that ln. So it's a lot easier for us to write. So what does this actually mean? You can find ln on your calculator. It's pretty easy to find. So go ahead and look for that button right now on your calculator. You're going to want to find ln of 6. So you're going to type ln and then 6. You should get, when you push enter, 1.79. So what that actually means, that is log base E, because that's ln, right, of 6 equals 1.79. So basically, if you would want to get the right answer, you could have gone log base 6 over log base E. You would have gotten 1.79. What this means, E to the 1.79 power is approximately 6. About. So what we're going to want to do, writing and working with E. So rewriting into log form and then changing it back to exponential. So E to the 4th equals 54.6. So you're going to want to convert this into log form. So it's going to be log base of the base, log base E of 54.6 equals 4. Okay, but you're not done. Log base E. You're going to want to rewrite this as ln of 54.6 equals 4. So log base E is ln, and ln is log base E, which comes back to our next question. We need to write in exponential form, so change ln into log base E. Like that. So now we can convert. We have a base of E. Answer is your exponent, 1.079. Equals the middle number, so equals 12. If you would try that, you're probably not going to get exactly 12 because we've rounded, of course. But you can easily check it on your calculator and see if it actually kind of checks out correctly. So what about evaluating these without a calculator? Dun, dun, dun! So let's evaluate this. First, you're going to rewrite in exponential form. So this is log base E of 1, right? Equals x. We don't know what x is. So let's rewrite. So we have E to the x equals 1. So in my head, I need to think, what exponent would give me an answer of 1? 0, right? So x has to be 0. Simple as that. What about this one? So log base E of E equals x. So we got E to the x equals E to the first, right? There's technically a 1 there. Don't think too hard. What do you think x has to be? It has to be 1, right? So x has to be equal to 1. That one's not too bad. Don't think too hard on these problems. Trust me. Log base E of E to the second equals x. So we have E to the x equals E to the second. X has to be 2. X has to be equal to 2, right? Makes sense? So what about this? ln, so we got log base E of E to the negative 3 equals x. So E to the x equals E to the negative 3. X has to be negative 3. Notice how ln and E kind of basically cancel each other out. They're opposites of one another. Pretty awesome. You're always going to get the answer that you're left with. Just a little note to kind of keep in the back of your head. ln and E are inverses, which helps us graph these. So just like when we would try to graph the logs, we need to be able to graph ln. You can't really graph ln, you're going to graph e's. So we have log y equals natural log of x plus 1. So this is technically y equals log base e of x plus 1, right? So now let's convert to exponential. So we got e to the y equals x plus 1. I'm not solved for x yet, so let's subtract 1 from both sides. So we got e to the y minus 1 equals x. Wonderful. So now, just like last time, you're going to plug in for y and not x. So it's going to be -2, -1, 0, 1, and 2. So now, if I plug in -2, you're going to get e to the -2 minus 1. That is -0.86, approximately. If you plug in -1, you're going to get -0.6. That's not a 6. There we go. 6.3. Plug in a 0, you're going to get 0. Plug in 1, 1.72. And 2, you should get 6.39. So let's graph that function here. I have -0.86, -2. So it's going to be right about here, down -2, right there. -1, -6.3, about there. 0, 0, perfect easy place. 1, 1.72, about right there. And 2, 6.39, about right there. Whoops. So now, hold on. I messed up. I started looking at my x's and my y's. So what x is 1.72? So that was 1.721. So I'll be right there. There we go. 6.39 up to 2. There we go. Now we got a function that looks correct. Almost messed up on camera. There we go. So, just like last time, you can have an asymptote on these guys. So let's draw on our asymptote. We have an asymptote. It looks like it's right here. Right there. So my asymptote is x equals -1. Just like that. So that's how you graph a natural log function, or a natural log. Change it into e, and then you can graph using plugging in for y's. Just kind of like what we've been doing with the log and the exponential form. And that's the end of this video. This is Miss Marsh, signing off.